Continuing on to look at molecules to decide whether they will act as acids or bases in solution, we're going to focus our attention on salts. We're looking for molecules that don't start with an H or don't end with an OH. You should be familiar with the anions that are incapable of hydrolysis, as well as the cations that are incapable of hydrolysis. Go back and review previous videos if you can't remember, but essentially you should understand that these anions are the conjugate bases of strong acids, therefore they cannot hydrolyze and turn back into those acids. And these cations are very soluble in solution, especially with hydroxides in particular, and therefore we would call them incapable of hydrolyzing. So on the previous chart, there are two examples of salts which will not cause a change in the pH of solution. Sodium chloride, because both the sodium and chlorine will 100% dissociate from this salt and will not further change the pH of the solution when in an aqueous solution. Similarly, lithium and nitrate ions do not hydrolyze. So the pH of these salt solutions will be exactly 7. They will be neutral. Another consideration is looking at a salt that does dissociate completely in solution, is completely soluble. However, when you look at those two ions dissolved in aqueous solution, we recognize that hydrolysis does occur for both the cation and the anion. And so in order to determine its final activity in that aqueous solution, we would look at the strength of the cation as an acid and the strength of the anion as a base. And in this particular instance, the anion and cation have equal ionization in solution and therefore effectively cancel each other out and remain completely neutral pH. So we can go to our chart now and say that we are comfortable with salts that are completely neutral in solution because they don't hydrolyze, and salts that are neutral in solution because both ions hydrolyze to the exact same extent.